Lesson 3-3, Solving Systems of Inequalities by Graphing. A system of inequalities means two or more inequalities with the same variables. To find the solution of the system, you need to graph the inequalities and figure out where the shaded regions overlap, and then any ordered pair in that shaded region is the solution. So there's multiple solutions, an infinite number actually, when you solve a system of equations. So the first one is y is greater than negative 2x plus 4, and y is less than or equal to x minus 2. Let me graph the first one in red. The y-intercept is positive 4, so on my graph I can start with a dot there. And then the slope of the first inequality is negative 2 over 1. The slope is always the number multiplied by x. Alright, so I'm going to make my line kind of long here because I'm not really sure where the regions are going to overlap. And now pay attention to your symbol. It's strictly greater than, and so my line is going to be dashed. What this means is the ordered pairs that are on the line are not included in the solution region. Okay, I also need to remember to shade, and the greater than sign tells me to shade above the line. So this is the region that we're looking at up here. Okay, that's good enough. Now I'm going to graph the other one in blue. Y is less than or equal to x minus 2. The y-intercept is negative 2. I'll start there. And the slope is 1 over 1. Up 1 over 1. Here's where they're going to intersect at 2, 0. But I'll keep going with my line. There we go. Now this one I can make a solid line because there is an equal to underneath the inequality. There we go. And this one says y is less than or equal to, so my shaded region is below for this graph in that area. And now the solution to the system, meaning both inequalities together, is where the shaded region overlaps. And so what I suggest when you do this with pencil is to shade your regions very lightly, and then once you figure out where they overlap, go back in and shade in that solution region a little darker, and I'm going to make my solution region in green. So here's the boundary of the blue line. That's solid. Then we've got a dashed boundary here, and then everything in this overlapped area is a solution. So in order to be a solution, it has to be in both blue and red, and so I'm making my solution region green. Okay, so some solutions to this inequality would be the 0.40 or the 0.62. Those are in the solution region, and you can see that this solution region is going to keep going forever and ever and ever, so there's an infinite number of solutions. Here's another one. Y is greater than 1/2 x plus 1. Y is less than 1/2 x minus 3. Now the first thing I notice about these two inequalities is that they have the same slope. They both have a slope of 1/2, but it is possible, so well, I know the lines are going to be parallel, but I was going to say it is possible that the shaded region is either in between the parallel lines, or the shading could go in opposite directions, in which case there's no solution. Let's find out what happens. So I'm going to graph the first one in green. The y-intercept is positive 1, and my slope is up 1 over 2, slope of 1/2. Go to the left as well, and my line needs to be dashed here. Okay, so greater than means I'm going to shade above my line. There's the shaded region for the first one. I'm going to make my second graph in purple. I've got a y-intercept here of -3 for the second graph, and then up 1 over 2 is my slope. So I knew the two lines were going to be parallel. Let's see if there's an overlap in their shaded regions. Again, a dashed line because the symbol is strictly less than. And actually the shading is going to go in opposite directions. Less than means shade below the line. Now this shading again goes on forever, but to find the solutions here, I'm looking for an overlap in the shaded regions, and these shaded regions will never overlap. and so there's no solution, no solutions at all to this system. All right, here's another one, example 2. The difference here is that I've got an absolute value in the second graph, but not a big deal. Let me show you what this graph looks like. So the first one is y is greater than x plus 1. Start at positive 1 for your y-intercept. The slope is up 1 over 1. Now this is going to be a dashed line because y is strictly greater than this line here. So I'm going to make my line dashed. Oh, I got off the path a little bit there. Okay, there's our line. Let me see if I can erase. That looks better. And greater than means shade above. So again, you should do this really lightly with a pencil because you can color in darker later where the overlap is. Because I'm graphing not just one inequality, but 2. Okay, so then the absolute value graph. Let me show you what to do with that. Use blue for this one. The absolute value of y is less than or equal to 3. That means there's 2 possibilities here. Y could be less than or equal to 3, positive 3, or y could be greater than or equal to negative 3. So when you see the absolute value of y, there's really 2 cases. Y is less than or equal to positive 3, or y is greater than or equal to negative 3. Okay, so these are going to be horizontal lines. The first one is at positive 3. Y is less than or equal to positive 3. That means my shading is going to go below. Then I've got y is greater than or equal to negative 3. Make my line a little bit better. There it is. And this one's going to go above. And so the shaded region here for the second graph is in between these 2 lines here. Now I want the overlap of both inequalities here. So again, I'm going to pick a different color. I'm going to choose black, I think. There we go. I'm going to choose black and I'm going to color in just the shaded region. So here's a boundary with a solid line. Once I get to here where they intersect, now I've got another boundary with this dashed line. And then down here at negative 3, I've got another boundary with a solid line. And my shaded region is just this area on the left where the graphs have overlapped. Okay? That's our solution region. And again, you could certainly name some solutions to this inequality. I could say that negative 3, 3 is a solution because that's included in this set. Or negative 5, 0 is also a solution. If I wanted to know the corner points, I can see that the corner points are at 2, 3 right there. And another corner would be at negative 4, negative 3, it looks like. Okay, so those are easy to find as well. Okay, finally, try this one on your own. They're easy for you to graph because they're in slope-intercept form. Think about if your line is solid or dashed, where you should shade each one. And remember, your solution region to this system is where those shaded regions overlap.